Sneha from the Web3 Compass, and this is day 26 of 30 Days of Solidity, where every day you level up not just by reading about how smart contracts actually work, but by actually building things that feel like real world applications. And today we're going to be shifting gears from minting NFTs to monetizing them. And before I get started, a little bit of introduction. For everyone who still doesn't know what this campaign is all about, this is our YouTube channel at the Web3 Compass. And for the past 26 days, we've been building content, shooting videos around various concepts on Solidity, and now finally we're dealing with real world applications. So this is your place to be if you're looking to get started with writing Solidity or exploring Web3 and blockchain. And if you're more of a reading person, then you can head over to web3compass.xyz, our website, and that is where you can find all the details. Now let's get going. So today we're going to write an NFTMarketplace.sol contract where we'll be building a marketplace for buying and selling NFTs. You will learn how to manage listings and royalties, demonstrating NFT trading. It's like a digital store for collectibles, showing how to create NFT marketplaces. Now, quickly, I think in one of the latest days is where we built a simple NFT contract, day 21. Yes, so yeah. So day 21 was when we talked about building NFT contract. So it is really important for you guys to be aware of what we're doing it here, because we'll also be using this contract and then, buying NFTs for the same. And this NFT.sol is the contract that we have talked about in simple NFT. And today we're going to write the contract for building your own NFT marketplace. Now, let's talk about marketplaces a little bit. Think of your favorite online marketplace. Maybe it's OpenSea, maybe it's Etsy, maybe it's your neighborhood flea market. I mean, it's not online, but still, they're always the same three roles. Someone selling something valuable, someone buying it, and the platform in the middle that handles the transaction. Takes a cut, moves the good. Now that idea is put purely on chain, no middleman, no backend, no one standing in the way. Just a smart contract that lists NFTs, these digital arts. Again, I'm not getting into the definition of what an NFT is and how do you write it and all of that. If you don't know all of this, go back to our day 21 video. But yeah, coming back to NFT marketplace, we're going to talk about a smart contract that lists NFTs, handle ETH payments, pays out the seller, the platform, and even the original creator automatically. Now, why is this project important? Is because we're looking into ERC-721 logic, we're looking into secure ETH transfers, we're looking into features like royalty for creators, fee distribution. We will even look into reentrancy protection, ownership, approval flow, all of that. It's the kind of contract that shows you how real world Web3 applications work under the hood. And when you build this, you're not just copying OpenSea, you're understanding it, creating your own stripped down, basic, no bloat version of OpenSea. And what you're going to learn today is how to list an NFT with a custom price and optional royalty, how to buy an NFT using ETH, how to unlist an NFT if the seller changes their mind, how to protect everything with the reentrancy guards, and how to track and update fees with full control as the contract owner. Okay. By the end of this, you will have all of this implemented. And now, how this NFT marketplace contract actually works is that it's fully on chain. It lets people list their NFTs for sale, setting a price for even like a custom royalty, buy NFTs for sending ETH directly to the contract, automatically split the sale between the seller, the creator, and the platform, cancel listings anytime, and update fee settings as the marketplace owner. All of this happens very, very securely with built-in protections like reentrancy guard to prevent attack. There's no front end here, no JavaScript, no backend, just a smart contract that is tracking every listing, verifying every NFT, the seller moves ETH and NFTs correctly, emit events so UI can follow. Now, if you want to build a front end for it, definitely go forward, but I really suck at making front ends. And yeah, I mean, I could do that with vibe coding and stuff, but yeah, that's not exactly my thing. So we will stick to smart contracts as of now. Okay. So yeah, let's get started. We have to first import a few things, but yeah, let me create a file first. NFTMarketplace.sol. Yeah, okay. So we've done this, and now we're going to import two of the OpenZeppelin libraries here. One is the ERC-721.sol, and the other one is a reentrancy guard.sol. Okay. Now, what is the use of it? It's exactly like it's for the first one, it brings an interface for any other ERC-721 contract, which is an NFT contract standard use for non-fungible tokens. Again, ERC-721 has a lot of ERC-721 has a lot of things put together. It's like a contract blueprint that defines who owns a token, how to safely send a token, how to approve someone to transfer your NFTs. By importing this, we can interact with NFT contract, not just NFTs we created, but any ERC-721 compliant contract like Bored Ape or a custom in-game item, etc. We don't need the full NFT contract here since we're not creating NFTs. We will use our previous code for that one. We're just working with existing NFTs, so we only need the interface to call their functions. Now, for the reentrancy import, this is a security tool. Again, we've talked about reentrancy in a very, very detailed manner. I think day 20 it was when we wrote the Fort Knox reentrancy guard thing. This is a security tool that helps protect our contract from a common type of hack called reentrancy hack. Again, I'm not going to talk about what all of this is. You can watch the Fort Knox reentrancy attack video for that, but we'll get started. Okay, we just know that it's an important thing to have. Okay, so yeah, we will now get to writing. So we say contract NFT marketplace is reentrancy guard. Okay, so this line kicks off the actual smart contract, and it does two big things. First, it names our contract as NFT marketplace and inheriting from reentrancy guard. So by doing this, our contract automatically gets protection from reentrancy attacks on any function where we use a non-reentrant modifier. It's like giving our sensitive functions a personal bodyguard. Now, why the setup matters? Again, we're just dealing with two imports and a declaration, working with any ERC-721 contract, keeping our marketplace safe from critical vulnerabilities. Now, for state variables, we will just get started. We'll say address, public, owner. Very simple. We know that the owner of the contract is the one who is deploying this. Then we are saying uint 256 public marketplace fee %, right? Now again, we'll take this in basis points. So maybe just 100, which is equals to 1%. We've talked about basis points already. And address public, who will be the fee recipient for the marketplace? Yeah. Okay. So, sorry. Yeah. Okay. So, what these variables are doing. It's basically talking about who's in charge, how much fee does the marketplace take, where does the all of these fees go, and all of that. Okay, now we will look at a few structs and mapping. So we're saying, oh, how did I reach here? Oh, my mouse moved. Yeah. So we say struct, and then we make a struct for listing, because come on, that's the first thing that we have to think about. Like, okay, imagine that we have the NFTs already, right? Now we need to list it on the marketplace. What would we need? So we would need address seller, address NFT address, right? UN256, token ID, UN256, price, makes sense. Address who is supposed to get the royalty, because the royalty generally goes to the person whose art it is, who to whom the art actually belongs. UN256, what is the royalty percent in basis point? Percent, and then we're saying, oh, pool is listed, right? So we have to make sure that the NFT that we're trying to sell, or someone is trying to sell or buy, is actually listed out there. I mean, if you're trying to sell, you have to list it, but yeah, it might be listed and you've forgotten about it. So, yep. Now that we've written this struct, we will write a mapping. We say, hey, we want the storing of all the listing at one place. So the first thing would be address. It's a nested mapping that we're talking about. The first key is the NFT contract address, which would be mapped to the token ID. Okay. Yeah. So the second key is the token ID. So if you want to access the listing for a particular NFT, you will just use the name of it, like UN256, and then listing, and then you will maybe write public listings. Okay. Need to close this one. So then for listings, you will just call listings, NFT address, token ID. Now, why are we doing a nested mapping again? Is because this allows multiple different NFT collections to be supported all in one contract. Again, very scalable, clean, works well with any ERC-721. Okay. So this is one mapping that I could think of. Now, what are the key events that you can think of? Okay. So first would be obviously listed. Sorry. So we say address, index, seller, address, index, NFT address for the listing, right? UN 256, indexed, token ID, makes sense. UN 256, price, right? Then address, royalty, receiver, and then UN 256, royalty percent. Okay, wow, that's a long one. Maybe try writing like this. Okay. 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 Great. Looks neat, right? You could not have been able to see it from this screen. Now, maybe someone made a purchase, right? Again, what would we need here? So we need address of the buyer. We will need an NFT address. Obviously, we will need token ID. We would need price. We would need seller's address, royalty receiver, royalty amount, and marketplace fee amount as well. So All of these are definitely there. Okay. So what we will do is change this to who the buyer is. There's NFT address, there's token ID, there's price. Then we will write maybe address of seller, right? Then address royalty receiver, a UN 256 royalty, not percent, but more like amount. Okay. And then we would also want you. So we have UN 256 royalty amount, and then we might have like a marketplace fee amount, but instead of percentage. Oh, too many fee deductions already. Okay, great. So we'll have it here and we'll have a comma. Great. Right? Now, what is it that you can think of? Probably unlisted if something goes out of listing, right? So we say address, indexed seller, address, indexed NFT address, and then we say UINT at 256 indexed token ID. Great, very smart. Nice, like it. Okay. What else? What else? Maybe fee updated? Yeah, I mean, you can add as many events as you want. These are all like good things. So it would be, it should be new marketplace fee. That's it, not percentage. And then we would say address, a new fee recipient. Okay. So here what happens is maybe you have like a entirely new owner who wants like a maybe better fee, better like whosoever is managing the platform. So then probably, you want these things to be updated. That is why we have written event fee updated. Great. So all of this is probably self-understandable, right? Now we will just go about writing a constructor. A favorite thing to do altogether. Okay. So we say there would be a fixed market fee. I mean, we'll deploy it with market fee percent. Oh my God, what have I done? Should really look at the screen and text. Okay, that's one thing. And then what is the address of the fee recipient? Okay, great. Now, in the constructor, we will check a condition if marketplace fee is too high, right? So if the market fee, place fee percent is less than equals to 1000, great. Otherwise, marketplace fee too high. Maximum is 10%. Again, we're talking in basis points. So one here is I mean, what percent would be 100 basis point? So then, yes, one basis point is 100. So then probably 10% is, 1000. And that's all we are bothered about. Okay. Okay. Once that condition is okay, we'll check another condition where the fee recipient's address should not be a zero address. And then you can just write zero address here and just be fine with it. And then you do owner equals to message dot sender. Then we say marketplace fee percent is whatever we have declared, and then the fee recipient is gonna be fee. Okay, yeah, pretty much it. Very simple. Set how much fee the marketplace will take, decide where those fees should go. It's a DAO treasury, a dev wallet, or a individual person's wallet. Automatically become the owner slash admin of the contract through that. Now, the basis points part is also clear, so that's fine. Now, what are we going to write? We have talked about modifiers before, so we will go about declaring a only owner modifier because we want certain things to be very, very limited to only owner of the contract, right? Now, this is pretty simple. Come on. We just have to check a condition, message.sender. We've written it 1,000 times. Okay, a few times already. Right? Only owner can. Okay, great. And we just put an underscore and just go about. Okay, now you're done with modifier. We know that in Solidity, a modifier is like a reusable guard clause. You can attach it to the function to require certain conditions before that function actually runs, right? So now let's just get to writing the function. Okay, this was all very simple, again, repetitive. So let's start with set marketplace fee percent. We're saying uint 256. What is the new fee gonna look like? And then we say, hey, it has to be external, but also only owner. Okay. And we check require is the new fee less than equals 2000. Again, basis points. Otherwise, market place fee is too high. We can't afford that. Why have I put it like this again? Okay, that is then we do marketplace fee percentage is equals to new fee, great, and then just emit fee updated, new marketplace fee. Instead of that, we will have new fee, and the new fee recipient is just going to be the fee recipient. Great, that's pretty much it. So this function basically allows the owner of the contract to change the marketplace fee, the percentage that the platform takes on every sale. It's useful for adjusting fees as your platform grows, reducing fees during promotions, increasing fees to sustain operations and all of that, right? So that is pretty easy to implement. Now what we'll do is we will write a function set fee recipient, okay, in case we want to change that. Okay. Function set fee recipient. Okay, great. What is the address of the new recipient? Right? Great. Now let's make this external only owner. Fine. Now what we do is we check if the new recipient address is not an address 0. Pretty understandable condition here. We've written this multiple times. And then we say, hey, the fee recipient is going to be the new recipient. Great. And then just say fee updated. Why? Because this is where we were going to talk about any changes, either in the fee percentage or in the new recipient of the fee. Okay, so basically the fee recipient is the address that collects the marketplace's share of every sale. It could be founder's wallet, a DAO treasury, a multi-sig that is managed by a team, or even a smart contract that splits revenue even further. So then you have to change it over time. Okay, now we'll get into some real implementations where we say maybe list NFT. Okay, so let's just go function list NFT. Now, here we would need the NFT address, take a lot of parameters. Okay, then it would take token ID, great. Then it would take price. Great. And then it would take the address of the royalty receiver, and then it would also take the royalty amount or percentage. Percent. Okay, great. Now what happens? So we will make this external here. Okay, now you should be good. Great, we're back here. Okay, so now here you will check a few conditions like price is greater than 0. Price must be above 0. Great. Okay. Now require again royalty percent has to be less than equals to 1,000. Otherwise, it says, hey, you know what? Maximum 10% of royalty is allowed. Okay. So we want to put this condition. Okay. Now we will also check if the listing is already there. So we will say listing mapping NFT address and then token ID. Okay. And then dot is listed. Okay. If it is not, great, go listed. Otherwise say already listed. Now these are some basic things that we will look at. What was again? What was the mapping's name? Listings. Okay. Great. Fine. Now these requirement conditions are very, very simple to actually, figure out. Now we're creating this. Now, once we have, listed all the basic validations, it's time we interact with the NFT. So for that, we cast the address. Okay. We say ERC-721 and then NFT. Okay, address, right? So we cast the address into an ERC-721 contract interface. So we can call standard ERC-721 functions like owner of, get approved, disapproved for all, etc. And then it's time that we check the NFT ownership and approval. So we say NFT. We say NFT dot owner of, right? Token ID is equals to message dot sender. If yes, great. Otherwise, not the owner. Okay, that's how you do the listing part of it. And then once you have done that, it's also important that you check if there's enough approval around it. So maybe NFT dot get approved token ID. Again, for you to be able to understand all of these functions, where is it coming from? You can go to our previous video or just check out ERC-721 implementation by OpenZeppelin altogether. And then we're checking approval. So one is either get approved or is approved for all. So if you're looking for the marketplace to have the ownership, then you'll have to have the address of it, right? So you will check that if the owner has approved for all, then this address has to be a part of it. Okay, that is there. And then you say, okay, NFT is or maybe marketplace is not approved, right? Let me just put it here. Yeah. Okay, great. So these requirement conditions are checked. Once it is all passed, we say listing NFT address and then the token ID. And then we call the listing struct, and we say seller message dot sender, just like how parameters were given. NFT address is NFT address. Great. Token ID is token ID. Great. Then price, because these are all same variable names. Price is price. Then we say a royalty. Oh my God, where have I started writing? So here we're saying royalty receiver is again royalty receiver, royalty percentage is listed is equals to true. Yeah. And then you just emit a function, event, where you see, okay, listed is, sender is dot sender, others NFT address, token ID, price, royalty receiver, royalty percent. Yeah. That's pretty much it when we are doing the listing NFT. Again, everything is self-explainable. If you've ensured that the caller actually owns the NFT that they're trying to list, so that someone else does not, put their NFTs on listing, and the marketplace must be approved to transfer the NFT on the user's behalf. This is required so that the contract can send the NFT to the buyer when it's sold. So once you've checked all of that, you can save listing info on chain. So we create listing struct and store it in our nested listings mapping. And this is now like a live listing on the marketplace, which is discoverable by anyone, and then you emit the event. So this logs the listing on chain, UIs can display it, indexes like the graph can track it, users can see activity in real time. Okay, now we're going to write the buy NFT function, which is again the heart of the marketplace right here. So when someone finds the NFT and they like it and clicks buy, this function is what actually makes the trade happen. So let's just get writing. Okay. So we're saying function buy NFT address NFT address. Then we say UNT 256. Token ID, and we're saying external payable non-reentrancy. Now again, this is happening because, no, I'm not going to explain it. We've already non-reentrant. So this is kind of a attack which does not let you maybe call a function that could exploit, any event that's happening. Again, if I have to explain it in layman terms, I would have said that, okay, wait, you can just go. Okay, so we make it non-reentrant. Again, this is to protect from the reentrancy attack. We've talked about this in detail, so you can go watch that video. Now, what it does is, so we'll first look into loading the listing. So we're saying listing, actually, to use the struct. So we're saying listing memory item is equals to, then we call it from the mapping. So we say NFT address, token ID. Okay, fine. So we fetch the listings from storage into memory so we can read it details, price, seller, royalty, etc. And we will look into a few validations. So we will check is the item is listed. If yes, great, and not otherwise it says not listed. Then we check message.value is equals to item price. So we are getting the right price for it, nothing more, nothing less. If that is the case, great. Otherwise, incorrect ETH sent, right? Now the other required condition would be that the item dot royalty percent plus the marketplace fee percent has to be less than equals to 1000. Again, we are talking about the price in the basis points, right? That is why it's 1000, which is like 10%. And we say if that is the case, great. Otherwise, just say combined fees exceeds 10%. Okay, I'll just instead make this one the, yeah. Okay, fine. So now what do we do? So we have to calculate a few things. So let's look into what is the fee amount calculation after we've put in so much conditions there. So we say fee amount is message dot value into the marketplace fee percent, okay, divide by 10,000. Okay, so we break the total ETH, that is the message dot value, into 3 buckets: marketplace fee, creator royalty, seller's actual earnings, and all calculated in basis points for very precise fee logic here. Yeah. Okay, this is unused. Great, fine. Then we say UN 256 royalty amount is equals to message dot value into item dot royalty percent. Okay, again divided by 10,000. Then we say UN 256 seller amount is equals to message dot value minus the amount minus the royalty amount. So that is how we're doing all the division. We're saying fee, marketplace fee, creators royalty, and the seller's actual earnings. Now we'll also put a few conditions like if the fee amount is greater than 0, right? So then we're saying payable. Who is the person? The fee recipient, right? Dot transfer fee amount. Yeah. So ETH goes to the fee recipient. This could be the platform, DAO, or even a dev wallet. Now, another condition is that if royalty amount is greater than 0, and then item dot royalty receiver, did I write wrong spelling? No. Okay, is not equals to address 0. Okay, then what do? We say, we make it payable, and then we say item dot royalty receiver dot transfer royalty amount. Right? So if the listing has a royalty info, the specified address gets a cut. So this supports creator earnings on secondary basis, a huge feature in the NFT space. And then comes paying the seller. So we are just saying payable item dot seller dot transfer the seller amount. Great, a very simple. Whatever's left after the fee, the royalty goes to the person who listed the NFT. And now it's time that we also transfer the NFT. So we say ERC-721 item dot NFT address. Again, dot safe transfer from. This is something that we've discussed in detail when we're dealing with simple NFTs in one of our days, I think 21. Yeah. And then we say safe transfer from who again? So we say item dot seller, like this. Item dot seller this will be item dot seller, then it would also be message dot sender. Again, because we're using transfer from, and then we say item dot token ID. So you might have to look at, how this save transfer from function is implemented. If I show you here, yes. So there's address from, address true, token ID, and then some data. So yeah, that is how you look into it. Now the contract moves the NFT from the seller to the buyer using the standard ERC-721 transfer functions. Again, this will only work if the seller has approved the marketplace during the listing. Now, once we're done with, the listing, the transfer, everything, so we will just delete the listing because it's no longer required. So we just list the NFT address, token ID, and then we would emit purchase again. So what are the parameters here? The buyer is the message.sender. Okay, NFT address is NFT address, token ID is token ID. The price is a message dot value. The seller is item dot seller. You can call it like this because we had this here, transferred everything to the memory to read it. Then there's item dot seller, item dot royalty receiver, then royalty amount, and then also fee amount, right? I don't know why this came as a double. Okay, so that's the purchase. Great. If I get it from here. Okay, so this is pretty much clear, right? Okay, now what do we implement next? Now, if we're doing something listing, we might want to cancel listing also if we have made up our mind that, oh, this is not working out, right? So we just give the address, NFT address, UN256 token ID, make it external, and then, come on. Okay, fine. Now we check it, we bring it first into the memory. So we're saying listing a memory item is equals to listings NFT address and then token ID. Okay, so it basically lets the seller of the NFT remove it from the marketplace before it's sold. And yeah, you can change your mind about selling, blah, blah, blah. So just like you were loading the listing initially to be able to read the details, here we load the listing, check it, like bring it back from storage to memory so we can inspect them, and then check a few conditions. We will say require item dot is listed. If it's true, great. If not, then it's not listed. Then we also check if item dot seller is equals to message dot sender, because if not, then this person is not the seller. Okay, great. Now what happens? You just want to directly delete the listings once you have verified all the validations. Where am I writing it? Listings, and then we say NFT address, and then we say token ID. Great. And then we say emit unlisted. Again, seller is message.sender. NFT address is NFT address. Token ID is token ID. Right? Great. Now we'll just write two utility functions. One would be around a get listing, and yeah, I mean that's all I think. Yep. So we say function get listing. Great. So we say, okay, we have to pass the NFT address, we have to pass the token ID, make this external view returns, and we say what? return, listings, NFT address, token ID. Correct. Now, this thing that we've done here is basically a read-only helper function. But what I wanted to say is we're missing out on something. Now, we have to make sure that we reject direct ETH transfers that we did somewhere else also in one of our previous days. I don't expect it. Okay, what should the returns be here? Again, yeah, that is why. Listing memory. Yeah. So we don't want any kind of direct transfers happening, so we have to block it. And for that, what we will do is put a condition in the receive a function, which is generally that if you're doing some ETH transfer and you don't know which function to call it, it will just automatically trigger when someone needs to send ETH. But here what we will do is revert direct ETH not accepted, because it has to go through the platform for to be able to make sure that the fee for the platform is there and the seller receives the right amount. There's a royalty percentage and all of that, right? And the second thing that we have to do is also reject unknown function calls, because the fallback is called when someone calls a function that doesn't exist in the contract or sends ETH without triggering the receive function. So in both cases, we don't want to accept the call or ETH. So we immediately revert with an error. So this prevents accidental misuse and ensures that users don't lose ETH by calling like typos like buy NFT instead of, BYU NFTs instead of buy NFTs or stuff like that. Okay, so we're saying fallback. Now we've talked about all of these functions, so I really hope that you all get it and that I don't have to explain it again. You can go to our previous videos for revision or even go through the written notes. Too tired to explain it again. Okay. So yeah, that's pretty much it. Now we will just go about deploying this. Okay. So what we'll do is, this is nft.sol. So we'll first compile this. And then we will, this name, the simple. So we say Web3 Compass. And here we just say oh, it's still loading. Sorry, guys. I don't know why is it that the NFT contracts get stuck all the time when it's deployment time, but let's get this going. What have I written? Okay. So when we deploy the simple NFT, we want to have a name and a symbol. So I deployed this. Now I will also go to NFTMarketplace.sol. And then, come on. Yeah, we need to compile it first. Okay, this is compiled. Now you will see that there's a marketplace fee percentage and then there is fee receipt, right? So what I'll do is I'll change the address here first, okay? So that our NFT contract is also not from the same contract that our marketplace is. If you are, you're trying to like sell your NFT and then try buying it, or I am only the owner when you're trying to buy the NFT, so then it has to be something else. Or maybe just let it be. I don't know what I'm trying to explain. Sorry. So we would put the market fee percentage as 250, again 2.5%. We're talking in basis points. And for fee recipient, we'll just take this address and we'll transact it. Okay, so there goes our NFT marketplace also. Now it's time that we mint some NFTs. So you have to call the mint function twice to maybe mint 2 NFTs. Okay, now there is address 2 and then there is URI. So what we'll do is we take this. We're trying to basically do it locally, and then there's already 2 things that we have uploaded in Pinata. So there was one web3 compass.jpg. Then we have to have NFT file for it. Then there's another 30 days of Solidity. So these 2 are the NFTs that we're talking about. And we do a NFT2.json and NFT3.json. Again, this is the JSON file that we've created. In order to understand all of this, you just have to go to our previous video to check it out. Okay, now what happens is, although I've given this, you can see it in OpenSea testnets. You will not be able to see it in the wallet, but yeah. So here in the URI, you basically have to give the IPFS link. So this is for 30 days of Solidity, right? I just copied this, okay? And the link is in a very different format as it would be. See, IPFS dot whatever. So then in Pinata, the link is very different what it comes to. So this is how you have to check it, ipfs.io/IPFS/ the ID that you're getting here, CID. Okay. So this is the first stamp's URI. So I will just copy this entire thing, come here, paste it here, transact, and that's done. Okay. So that is one thing. The second one would be my, this is the first one, Web3 Compass Stamp 1, Course 1 completed. And this is my IPFS link of the second JSON file. So I'll go back again here and I'll paste another URI here and transact. Okay. So now I have 2 NFTs minted. If you come here, let me expand. And there's event, then there's string URI, token ID is 2, and for the first one, it would be token ID is 1. Okay, so now you have 2 of them. So you've minted those NFTs using the previous contract. Now, if you check owner of, call this person, again, token to fine. Okay. Yeah, this 0 token does not exist. So 1, 2, this person is the, like, it's my MetaMask wallet, right? Now what you do is just go for set approval. So we're saying operator and approve. Okay. So set approval for all. Yeah, I think set approval for all will work. So we will just copy the marketplace's address, okay, with the actual address of your deployed marketplace. And then with bool, you just say true. Actually, no. Instead of set approval for all, we'll just go here and we'll say this and then token ID 1 transact. Okay, now not authorized because I minted that to my MetaMask wallet address. How stupid. Whereas my environment here was remix. So what I will do is I will, okay, I will copy this and see if this works. Okay, so this worked. And now if I check owner of token ID 2, Okay, that is one. And if I make this. Okay, so we made an error in the previous steps that we were doing. What I did was I minted the NFT to my MetaMask, whereas I had the environment as a remix VM itself. So we'll have to do it again. I go to nft.sol, I compile it, and I come here, I change it to this, I say Web3 Compass, and then I say W3C. Okay, I transact it here. Great, we have it. Now it's time that I mint it. Okay, so what I'll do is I'll mint to this account address to, and then this is my stamp one thing. So I'll just copy this here. This is stamp one, course one completed. So this is the URI. Again, to know about the process, go to my previous video. That is where I talk about all of this in detail. Now, if you want to check owner of, then I am the owner. Okay. Now, similarly, I will talk about stamp two. So I copy this URI and then I keep the address as mine, but I change the URI string, transact to. Now if I check owner of to, and then I'm the person. Okay. Now what I have to do is that there's a approve function here and I want to approve the NFT marketplace to be able to perform the further operations like selling to someone, etc. So I'll copy the address here and I say token ID and transact. Okay. Then I change it to 2 and transact. Okay, so this we have done. We've approved the marketplace from the simple NFT contract using the approve function. Now what happens? There's a list NFT function that we created in the NFT marketplace. Okay, and it needs a few parameters. It needs NFT address, so it will need my simple NFT contract address. Then it will need the token ID, which is like 1. Okay. Now I want to put the price as 1 ETH. Okay. So it will be 1 with 18 zeros. Okay. The royalty receiver would be my own address. Okay. I want to list this NFT and the royalty percent would be 500 because we're talking in basis percent. So we want to set as 5%. So let me see if this goes through. Okay, so this listing is done. If I want to get a listing for NFT address and token ID, I can get all of this information. Similarly, I can do it for 2 as well. So I transact it and then I check 2 and then it changes something here. Okay, so get listing is done. Now what? Now that we have listed the NFT for sale, it's time that we buy the NFT, right? So in the NFT marketplace, we are going to call the buy NFT contract. Now, the NFT address would be the simple NFT address. Okay, great. And the token ID would be like 1. Okay. And in the message.value, we would have 1 ETH because that is the price of it, right? But then I want to actually buy this from some other account. Okay. Now, can I transact this? Great. Now what happens? This gets deducted and this gets added on. We had spent some money here, but now it's 100.99, right? So what it does is that there's token ID from this to event transfer happened. 0 is this person is, again, can I check buy NFT? Sorry, NFT marketplace, buy NFT, or just, yeah. Okay, so address is one is NFT address, and then we're looking at, oh my God, where is it? For the listing, right? Yeah. So there's a seller Then there's NFT address, then there's token ID, then there's from, who's a royalty receiver, then to, royalty percentage, etc., etc. So you can check all of that information. And a fee went to the platform, NFT was transferred to the buyer. Now, okay, simply even if you would want, let me just paste this, let token ID. Now I will show you what happens here. So if I transact, there will be an error, right? Why? Because we've already sold this. But let's try to. Oh, sorry. Not even pasted the entire contract address. So I'm not the seller, sorry. Let me just show it with one. What happens if I transact not listed because it's sold, but then I transact and this goes away, right? So now if you do get listing for address and there's to token ID, everything's zero because the listing has been removed. So yeah, you can play around, see the NFTs. The best way is to try on MetaMask. Last time it was not working for us, as I've shown you this. The image would just not come, so we thought we would do it on Remix. But anyway, try it out. And you can check everything at OpenSea.testnets. So testnets.OpenSea, and you will get all those NFTs. We also have our previous ones here. And again, Pinata and everything is explained in the previous videos.